Hey everybody, in this video we're going to continue our work on making a calculator. So I think let's implement the rest of these functions and that'll be a great place. Alright, add numbers. Let's have this other condition. If the input choice is 1, then what we're going to do is actually to save some code here, I think instead of this result equals result kind of deal, we could just print out that. Save some code there. Okay, so let's kind of copy this right here and ask user for input. That'll be the same, and now we're going to subtract numbers. So subtracting numbers, I'm assuming if we say like 5 minus, like, so if we say 5, 1, 1 right there, I'm assuming that's going to be 5 minus 1 minus 1. So we'll operate under that assumption. So the result is actually going to be equal to the first index of the list. Now when I mean first index, the first element of the list. Now remember, in Python and usually in programming languages, the first element of a list is denoted with the index 0. So if you want the first of anything, we're going to do parameters of 0. So we'll have results, and that'll be the parameters of the first one. And now we kind of want to take from that and subtract every number from that. So to do that, what we can do is we can do this like I'll show you. We'll do this. Now what is this saying? So if I'll do this in a new window here. So what this is saying is that usually parameters, say that we have n elements, right? N elements. Usually parameters will be indexed from 0 to n minus 1, right? So we'll start at index 0 because that's how lists work in computer science. And we go into n minus 1, right? N minus 1 elements. So n elements, to access the nth element, we do n minus 1 because it's always minus 1. So what this is saying, parameters of 1 to the end, it's saying we're going to start at 1 because we don't want to start at 0 because that's already kind of included in our result. And this colon to the end here kind of means that we're going to include everything to the end. So we'll get rid of that. And we'll say for the parameters in there, we're going to say that the result is going to be equal to the result minus the current parameter. And we will have our result there. Likewise, I think we could bang out multiplication really quickly. This is going to be pretty identical to sum. And instead of plus, we'll just do times. And we'll call it mult numbers. Next up, we'll do quotient. And likewise, I'm assuming in quotient, if we have 5, 4, 3, for example, that'll equal to 5 divided by 4 divided by 3. So let's kind of build that out. And again, we're just going to take some subtraction. Copy that, and that'll be divide numbers. I'm thinking of quotient. Divide numbers. We take the first one and we just do that. Right, following that. Divide modulus. Again, what we're gonna have is probably 5, 4, 3. I don't know if this makes too much sense, but this would be 5, 4, and then 3. But it's probably at a good point right now to see if everything works. So let's do this quit, so we can actually quit the program. And what's quit's gonna do is let's put our continue condition up here. And what we're gonna say, so we put continue condition all the way up here, and all that's gonna say is that continue condition is gonna equal false. Because by the time we loop back around, the program will check for the while condition, and that'll be false. So quit program. All right, cool. So let's do this 9 right here for quitting the program, and let's see if everything works. So we'll have quit program. So we implemented multiplication and division. So let's add support for that. So 2, 3, and we already added 9 right there. So instead of add numbers, it'll be multi numbers. And instead of add, it would be divide. So let's just test this out. All right, let's do subtraction. So like 10, 3, and 3. So that should leave us with 6. We made a mistake here. Let's see what happened. So we have the first number here. And that's interesting. So I guess it added them. Oh, did I do one? Wait. I made a mistake there. I did not change out the method, the function. So now's a good time to see if 9 works. Oh, it does not. And that is because I guess this variable has no idea, if it's done in here, has no idea whether or not the continue condition is true. Because this continue condition, it's pretty ambiguous to the program that this is referring to the same one. So what we can do instead is we say while it's true, we just continue executing, and when we eventually hit on quit, we just will do a manual exit of the program with the exit command. Okay, and to quit a program manually, just do Control D. Okay, so let's try subtraction again. 10, 3, 3. We should be left off with 4, which we are, and quit still doesn't work. Oh, wow! I did not include parentheses in my program. I bet I bet Python's pretty confused what's going on. Okay, awesome. So that all works. And multiplication and division will probably work the same if we kind of copy the code right here. We should test it out, but maybe we can test. More testing is never a bad thing, right? So multiplication, let's say 3 and 3 and maybe 2. So that should leave us with 12. Good thing we test. What's happening here? Multiplication. Silly bug on my end. We start with the result equaling 0, so 0 times anything is always 0. So let's follow the similar format up here such that it's equal to the first number, and then for subsequent numbers, we will multiply it all out. See, this is why we test, and we shouldn't assume anything. So let's try that out. 3, 2, and 3, and we get 18. Or maybe I did 3, 2, and 2, which should have been 12, but it seems to work. Let's try out division. What'll be easy? Let's see. 36 and divided by 2 would be 18, and divided by 2 again would be 9. And we get 9. Okay, we're up and running. How cool is that? So let's do mod right now. It'll follow a similar format to division, I'm pretty sure. Never modded more than a couple things before, but so now we replace it with this operation. Cool. And let's see, what else can we bang out? Exponent. Again, if we're doing exponent here, I'm assuming 2, 3, 4 to be 2 raised to the 3 raised to the 4. I'm assuming that. So we can copy this again. And now we can say that. So that should and this should be exponent. So we take the result and we continuously raise it to a different power. And all right, well now's a good time to test it out. Okay, cool. So this would be 4, 5, yeah, 4 and 5. Great. So 4 would be mod. So we have mod numbers, and then we have exponent numbers. All right, let's try it out here. So the modulus, mod 5. Wait, our printing's all whack. Oh, I forgot to include a comma here. Yeah, I was gonna say. Anyway, 4 would be modulus. So let me think here. 9 mod 2 would leave, or 9 mod 4 would leave 1. 9 mod 5 would leave 4, which mod 2 would leave 0. Awesome. Okay, that worked. And we're gonna try exponent here. So let's see, 2 to the 3 was 8, to the 2 would be 64, so we should get 64, which we do. Awesome, this is looking great so far. Let's do logarithm. Now, for the logarithm, that is going to be interesting because we need to assume a base, and if you don't know too much about logarithms, honestly, like, don't worry about it. It's like, if we have, so like, if we have this file, right, if we, no, not a file, if we have like, log base 10 of 100, that would equal 2. It's saying like 10 to the what power equals 100. So I guess we can assume log base 10 for everything. Maybe we'll write that down. Assume base 10 for the user there, and we will define like we have been. I guess if you have 5, 4, 3, it would be log of 5, log that with 4, log that with 3. I guess, yeah. I guess a little weird, but we will go with it. So now what we do, since this is a math library function, we say this would be math.log, and I have the documentation up here. So we put the base second, so that'd be 10. And what we do is we say result base 10. Okay. No, parameter. Wait. I guess parameter? Wait. Let me think about this. So the first one modded with this logged with the second one. This is getting confusing. Honestly, we'll assume that they only provide one number for log number, because I don't even know what this looks like if you do multiple logs. So, and also only one number is accepted. Okay, I quite frankly have no idea what this all would look like. Anyway, so we'll just take this. We'll just return math.log of parameters of 0 and of 10. I'm not too sure what what it will kind of look like otherwise, but I don't know, maybe you guys can figure that out and answer in the comments section below. Alright, so we put that in there, and that would be log numbers. And now we'll do our good friends ceiling and floor from earlier. And again, right, it should only take in one like the ceiling of maybe one number, right? Like, again, I don't know what it looks like for multiple numbers in a series. I mean, maybe you can do it for each number, but we'll just assume like you do it for one number. So math.ceil and math.floor, the first parameter. Kind of makes sense. I mean, you guys could define like the behavior however you want it to be. This would be ceil number and floor number. And all these now should be good to go. Alright, cool. So that and that. So 7 and 8 log ceil numbers and floor numbers. Cool. Alright, floor number. Alright, now, great time to test it out. See if everything's working as it should. Alright, let's try this bad boy out. Log. So let's see. So if we have log base 10, we should say 10. That should give us 1. 10 to the 1 power is 10. Great. So we forgot to convert to a float. This is why we test. And float here. And why not throw in another float over here to be safe? Alright. 6 should be 10, should be 1, 7, 3.2 should be 4, and floor 3.2 should be 3. Awesome. Alright, we tested it out. We're good to go. So all these operations are good. So we can kind of like, I don't know, get rid of that. Delete it. History, clearing the screen, and freeform are what remains. And we can handle that in subsequent videos. See you guys in the next video.